All right, good morning. We're given a great opportunity here to look at BUFKIT with the approaching storm. Today's Monday, February 10th, 2025. Systems coming in on the Wednesday, the 12th. So within the name range, not maybe not fully sampled yet, but it'll be fun to look at BUFKIT, maybe learn some things and learn how to, look at some snow stuff. So I'll put in the installation link to BUFKIT in the description. I haven't really loaded much, so we'll do this together. So I'll just go to Google, type in BUFKIT PSU. This is from Penn State University. So I'm sure there's other sources you can use, but this is the one I use, just kind of used to it. And here you go, get BUFKIT right there. Right, easy. Here's all your models. So HER, Shref, GFS, NAM, NAMNest, right? The green highlighted ones mean that's a current run, the newest run you could use. Anything before that, of course, is the previous run, but the one ahead of it is yesterday's runs, right? So we'll be using the NAM for fun. It's been spitting out some fun numbers. So just click on 12Z NAM right there and click your desired little dot wherever you want to look at it. We're going to use DuPage. I could use O'Hare, but maybe some lake influence. I don't know. Just used to DuPage closest to it. So you're getting this huge list. Just use the URL up here. That's it. Copy it. We will now go to BUFKIT and upper right here. Mind the way? Nope. Okay. Click get data. So these are the default ones that keep showing up. You can just delete those if you'd like and just paste in the link, the URL you copied previously. Click get profiles. Pretty much done. So you'll just find your model. So not the HER, we're using the NAM. Click on the NAM and make sure you're on DuPage. For example, you want to make sure the date over here is correct, so February 10. Otherwise, the last time I looked at Midway was December 5th, right? Wrong. So either way, either it did not get imported correctly or just did something wrong. It's all right. So we're going to DuPage, and we're going to be looking at DuPage for this incoming system. So once you make sure the time is correct, the scroll wheel is over here. So it goes right to left. So it's a little different. I already have some things selected here because whatever is shown on the right is dictated by whatever I have selected here on the left. Vector winds, you can turn on, off, anything you'd like, digital winds, whatever. For me, I like to have omega here. So omega, here's the center line. And the more left it is, the more upward vertical velocities you have. And same with the opposite. So anything on the right is subsidence, sinking air. And the way you can tackle, sometimes this will go off the screen of how strong omega is. These values over here, -5, -10, -15, you can right click or left click on these. It just extends the values. So if you want to see more, or if it goes off screen like that, then you want to shrink that. Same with the height of the sounding. Click anywhere on the sounding, right or left click. I think that was the opposite. Right click, left click, right? So however much you want to see of this sounding. With addition to omega, I use snow growth. It's already highlighted here. These light dashed blue lines are the dendritic growth zone, right? So between -12 and -18 Celsius is where you're maximizing your snowflake production. And with the yellow highlighted here, that's your saturated dendritic growth zone. Anything purple, for example here, yellow saturated, purple unsaturated. So too much dry air, not saturated, not producing there. Anything else here, momentum transfer for winds, anything like that is very helpful. You can change from feet, kilometers to pressure, whatever you prefer as your horizontal to show your heights. We'll be using pressure in this case. And of course, there's other things we can use, but we don't have any severe, we don't have any lake effect snow. Perhaps in the future, some videos we'll be doing that. So the reason we like to use omega, and especially the DGZ as well here, I'll pull up the image here. So there's your -12 to -18 Celsius, or -10 to 20. And these are these fat dendrites. This is what you want for, snow to stack and accumulate most quickly. So that's your best flakes for stuff like that. Here, you get needles, hollow columns, prisms, whatnot, plates when it's super duper cold. You get different snow to liquid ratios. We'll go over that as well. But here, we really want this to be co-located with that upward vertical velocity, the omega, the negative omega. We want this because you get these fat flakes to form in this area, and the more air rises in this area is co-located, right? We want this as much co-located, as much negative as possible. It'll keep bringing those flakes back up and aggregating them, clumps, huge clumps of these dendrites as they fall. So till they get heavy enough and they finally fall, we get these fat flakes coming down. Otherwise, we have a lot of saturation in this -5 to -10. So we'll probably have more of these little columns or needles rather than, dendrites at most times probably. These omega values are nothing to write home about, unfortunately, but you never know. Sometimes these, again, there's just one run of one model. There's a lot of things that can happen. Looks like, this looks real fun. This is 5 p.m. on Wednesday, so rush hour pretty much. You're getting this real, pretty decent negative omega co-located perfectly with the DGZ here. So I'm thinking tomorrow, Wednesday's rush hour is going to be pretty brutal. There's multiple ways to view this, so we're going to go to overview, and this is where the fun and magic happens, in my opinion. So up here, upper right, we'll click overview, and we get this new window. All right, so we have the overview open, so we can click on something like temperature, for example, and again, the view is right to left. So this is Monday, Tuesday, Wednesday, and this vertical line goes together with this sounding, right? So as we move this, the sounding behind appears. So if you have two monitors, it might be a little bit more helpful, or just, put it side to side. We'll turn off temperature and use something more helpful, just like we were looking at omega earlier, right? So we'll click omega and take a look. So real strong negative values here. These red contours are negative values. It says -4, -9, etc. And blues, sinking air subsidence. You click right here where these stronger values are. You see it's more further left. These values coincide with the values up here, but just a different way to look at a little cross section. It's a lot more helpful. We can do multiple things. Well, you can change the contour level as well if it looks too busy or your value is really going crazy. The higher the number, the interval, the less information you get. We don't have anything crazy right now, so we'll just keep this up. Here we have omega and snow growth, so we can overlay both. So we can see where we really like it. So this DGZ, this dendritic growth zone, isn't too deep, less than 100 millibars, nothing crazy. But you get these better values of omega here, perhaps. So we got almost 100 millibars here, perhaps, with some pretty decent rising air through a large column almost from the surface, fairly weak, but all the way up to about 300 millibars or so. So I bet there's pretty good snow production right here at this time. Another fun one is using equivalent potential temperatures. This one is a little bit more complicated. Basically, bigger the spacing, or the more vertical these values are, the weaker the static stability is. So you might be able to get some of these convective bursts. So these upward vertical motions can get contracted and enhanced in those phronogenetic circulations. You can pretty much picture if a parcel follows a constant geostrophic momentum surface, and these theta E values decrease along that momentum surface, you can get that more convective type of snow. Especially, I have a better example here from a previous snowstorm. You could see these values pretty much ramp up vertically and almost fold over right here. You can see that the DGC is not even that impressive, yet these omega values are, and it was ripping pretty good at this time. This is from last year, January 2024. Next thing you can use is looking at snow. It will show you the snow ratios. So liquid to snow ratios. The next little tab here, you can look at precipitation. Again, look how small, click, unclick, all the way down here. So what you can do is right click these values down here. So this is just QPF. So pretty much if you were to melt down all the snow or whatever precip falls, this is how much it will be. So if left click does nothing, right click highlights that value there, so 0.1 inches. If that standard 10:1 ratio exists, this is an inch in an hour. If it's a higher ratio, for example 15:1, it'll be 1.5 inches within this hour. So we'll take a look at this in a second. We'll just turn off the precip and go to the snow tab and click snow. It goes off the map, off these values. So again, right click over here and it will be more manageable. So we'll right click there, it's 1.4. So why is it spitting out 1.4? Because this max temp and profile snow ratio is the value it's assigning. So this can be a variety of different things. So you can use cob method or different methods, but for our sake, we'll use max temp and profile. I think it's probably the most valuable one here. You can look at the snow ratios visually as well, like this. So you see as the system moves, the ratios change as well. So about 14, 15. So I think it's fair to say that it will average out about 15-to-1 ratios, but as the system moves, ratios change. They do not stay constant. You can change it to 12-to-1 and see what it would be like if we just do perfect 15-to-1, max temp and profile. And here's a real cool function. What you can do is not just right click and get that value. You can right click and hold and drag through the time period you want, and it will show you that total. So there's showing up two totals. The one on the right in parentheses is without compaction. So it's essentially adding hourly snowfall. And it says do not use this operationally because it is just, if we were just using and measuring every single one of these hourly snowfall and just adding it up. With compaction, snow accumulation, you can highlight that and look at the difference. This is with compaction. Again, we click and drag 6.8, and the further time we go, look at it fall 6.1. Sorry if I didn't mention that earlier, but these ratios, this light blue line. Here, let me turn some of these off. These are right values are snowfall totals, hourly, or the ratios are on the left side. So 15, 10, 20. All right, we'll turn these off for now. Obviously, there's wind. You can use these for a variety of different ways. For convection, we'll use this probably more for severe season and whatnot. So we already have all that information. There's so many moving parts, especially in a winter storm. So here's another fun example. There's this large positively tilted trough moving in. You get almost like a little bit of jet coupling here, right? And this is really cool because you can see if you have this jet, you have upper level divergence and it's left exit, right exit, you get subsidence, and inversely true here. So right entrance, you get some rising air. So we like rising air for snow, right? So we want to be on this area, but we can also be on the back side, the right entrance here a little bit. Left exit, right entrance. So we get some cool dynamics here that might hint at a little bit of period of overperformance during the Wednesday evening into the overnight hours at times. Vertical velocity is important. We want those. We'll zoom in here. Again, that is that white line, that white value there, right? Nothing too crazy. And this is just showing at 500 millibars. So BUFKIT's great because we get that visual every time frame throughout the entire sounding. We could do that here too, but it would take much longer. 700 millibars. We can also look at frontogenesis. Nothing crazy. You get that little band here. We'll see once other models come out and hint at maybe something stronger here. But for now, nothing too crazy. But any frontogenetic banding we'll get here in northeast Illinois, those totals will be enhanced for sure. Vertical velocity once more. Again, nothing crazy, but sometimes you get these really strong values. It's a lot of fun to look at. And 850, of course, we're talking about that, those photographs, that warmer advection ahead of it. And as I said, it's important not to look at one single model, one single run, because they do fluctuate a lot. Another great source is the metergram generator. I'll try to zoom in. You can see they have these cob methods and these max temp and profile, what we were looking at, right? So this does include compaction, as you see these values drop off, but you just have straight model run 11-to-1, so they just default to 11-to-1. So these are lower values than their counterparts of cob method or max temp and profile, because they know that that we will be above that snow to liquid equivalent of 11-to-1 will be 14, 15 or so to 1. But again, on average, we will be changing throughout as the system moves. So I hope this was helpful. Again, a lot of things you can use this for, and a lot of information you can take in. And it's very important to keep looking at storms like this because then you can get a comparison of what storm did what and what did you see on BUFKIT. Maybe make a note of it of sorts because there's so many different moving parts that you have to look at when you're doing this. And maybe there's another one coming on Saturday, so maybe I'll make another video and we'll compare the two and what happened and what should we expect. So thanks for watching, and maybe we'll make some more videos. Thank you.